The instrument and control panel system includes all fixed or movable panels and their components. The system is divided into several subsystems. The main panels, which include the primary instruments of the pilot and the co-pilot. The glare shield panel, which includes the guidance panel, the display and light control panels. The control pedestal, and the overhead panel, which consists mainly of arrays for controlling the aircraft systems. On the main panel, you will find all primary instruments. The main panel includes the pilot panel, the center panel, and the co-pilot panel. On the pilot panel, the following components are installed. The primary flight display, PFD1, the multifunction display, MFD1, the reversionary panel, and the footrests. On the center panel, the following components are found. The engine indication and crew alerting system display, ICAS, the integrated electronic standby system, the auto brake control panel, the ground proximity terrain inhibit push button, the emergency parking brake light, the landing gear warning inhibit push button, the ground proximity glide slope inhibit push button, the ELT panel, the landing gear control panel, and the clock. On the co-pilot panel, the following components are installed. The primary flight display, PFD2, the multifunction display, MFD2, the optional water dump button, the cabin light timer and reset button, the reversionary panel, and the footrests. The glare shield panel system provides protection against sun washout for the main instrument panel. Besides the guidance panel, the display and light control panels, the glare shield panel includes the master warning and master caution push button lights. The control pedestal has three primary sections: a control pedestal forward panel, a control stand, and a control pedestal aft panel. The following components are on the forward panel: the two multifunction control display units, the power plant panel, and the flight controls panel. The following components are on the control stand: two cursor control devices, thrust control quadrant assembly, a takeoff configuration button, the ICAS full panel, a ram air turbine manual release handle, and a speed brake handle. The following components are fitted on the control pedestal aft panel. 1 emergency parking brake handle, 2 digital audio panels, 1 ground proximity flap warning override control panel, 1 slat flap selector lever, a trim panel, 2 passenger address buttons, and the elevator and aileron disconnection handle. Most of the controls for the aircraft systems are located on the overhead panel. The overhead panel system is divided into subpanels, which have integrated lighting for night flight purposes. The subpanels and controls found on the overhead panel are the digital voice data recorder control panel, the electrical power control panel, the cockpit light panel, the fire extinguisher panel and engine fire shutoff and extinguish handle, the fuel control panel, the passenger signs panel, the APU overhead control panel, the windshield wiper control panel, exterior light panel, the cockpit hydraulic control panel, the pressurization control panel, the ice protection control panel, the air conditioning and pneumatic control panel, and the passenger oxygen panel. The clock is located on the cockpit instrument panel. It is used to display the Universal Time Coordination, UTC, elapsed time, and chronograph functions. The clock interfaces with the generic Input-Output Module 2 in MAU2 via an ARINC 429 bus. The clock receives GPS data and a weight-on-wheel signal, but provides UTC and date. Power is supplied from the 28-volt DC Essential Bus 1. The front panel consists of high-contrast transflective LCDs with blue-white segments on black background and control buttons. There are 4 digits for the chronograph functions, 6 digits for Universal Time Coordination, and 4 digits for elapsed time. The LCDs are backlighted and automatically dimmed using a photocell. 2 push buttons control the chronometer, and reset. A 3-position knob selects Global Positioning System Time, GPS, Internal Time, INT, or sets Universal Time Coordination and Date functions, SET, for the UTC display. The Date Set push and turn button allows you to set the date. A 2-position mode selector for the elapsed time is used to select the automatic mode, auto, or reset function. UTC is indicated from 0 to 23 hours 59 minutes and 59 seconds. A fixed colon separates hours from minutes and operates only when the function is initialized. With the 3-position selector set to INT, the clock displays its internally computed time. When set to GPS, the clock synchronizes and displays GPS time. Note, during initialization and set to GPS, the clock displays its internal time. When the clock is synchronizing with the GPS, when no signal is present, or when false or invalid data is received, the clock displays its internal time. It displays only dashes if the internal time is not set. Pressing the Date button displays the day, month, and year in place of the UTC, but the colon is not displayed. Leap years are taken into account. Elapsed time counting is possible from 0 to 99 hours and 59 minutes. A fixed colon separates the hours from the minutes and is seen only in the run mode. The display is blanked in the non-operative mode. In the auto mode, the elapsed time counter starts only if there is no weight on wheels. WOW is false. As soon as weight is on wheels, the counter stops. With weight on wheels, WOW is true, and selected to the reset mode, the counter is zeroed and blanked. Chronometer time is displayed from 0 to 99 minutes and 59 seconds. Pushing the RST push button blanks the display. Pushing the CHR push button once enables the display and starts the chronometer from 0. Pushing it a second time stops it. The DVD-R Digital Voice Data Recorder System is capable of receiving, recording, and preserving all required flight data parameters and voice recordings on board the aircraft. It combines the function of a flight data recorder with the function of a cockpit voice recorder in a single solid-state recording unit. The Digital Voice Data Recorder unit is capable of recording the most recent 120 minutes, 2 hours, of audio information, 25 hours of flight data information, 120 minutes, 2 hours of digital communication messages, and Greenwich Mean Time, GMT. The Digital Voice Data Recorder system has the following components. 2 identical Digital Voice Data Recorder units. DVD-R1 is installed in the forward E-bay. DVD-R2 is installed in the aft E-bay. 2 impact switches, one each mounted near its respective digital voice data recorder. 1 triaxial accelerometer installed on the wing stub. 1 DVD-R control panel located in the cockpit on the overhead panel. 1 cockpit area microphone mounted on the frame between both windshields. The Digital Voice Data Recorder control panel uses standard input-output interfaces for a cockpit voice recorder and a flight data recorder. The Recorder Test button, DVD-R Test, is used to initiate a cockpit voice recorder and flight data recorder test within both DVD-Rs simultaneously. You can switch the forward-aft switch position to check the test status for either DVD-R1, switch to forward, or DVD-R2, switch to aft. The status light illuminates for a successful self-test of the flight data recorder and cockpit voice recorder. For this function, the aircraft has to be on the ground and the parking brake has to be set. A headphone jack is available for audio monitoring. The position of the forward-aft switch also determines the CVR audio monitor source, forward or aft DVD-R. The cockpit area microphone, CAM, picks up area audio and delivers it to the preamplifier of the DVD-R control panel. The Digital Voice Data Recorder systems begin recording automatically. The cockpit voice data recorder begins as soon as power is applied and stops when power is removed from the unit. The flight data record function starts when the engines are turned on or when the aircraft is in the air. No weight on wheels. Weight on wheels is false. It stops when the aircraft is weight on wheels and both engines are turned off. The DVD-R unit is internally time synchronized for direct correlation of the recorded cockpit voice to flight data information. Additional Greenwich Mean Time information is provided for absolute time marks. In the event of a fault or failure of the DVD-R system, an advisory message on the ICAS comes on. Some DVD-R CAS messages will be inhibited during critical phases of flight. There is fault segregation between the CVR and FDR functions. Generally, a fault occurrence in the flight data function will not influence the normal operation of the cockpit voice function, and vice versa. The headphone jack on the DVD-R control panel, used for cockpit voice recorder audio monitoring, accepts a standard 600 ohm headset plug. The output at this jack is a composite audio signal representing all 4 channels of audio, the cockpit area microphone signal, and audio signals from the 3 audio control panels. Select the forward-aft switch for the required audio source, forward for DVD-R1 or aft for DVD-R2. To erase cockpit voice recordings, make sure that the aircraft is on ground, weight on wheels is true, and the parking brake is set. Press the CVR erase button for at least a half second. The recording will be erased within 5 seconds of activation, which is indicated by a 3-second, 400 Hz tone from the audio monitor. No visual indication is supplied. Note, recorded flight data and ancillary information are not affected by the erasure command. The headphone jack on the DVD-R control panel, used for cockpit voice recorder audio monitoring, accepts a standard 600 ohm headset plug. The output at this jack is a composite audio signal representing all 4 channels of audio, the cockpit area microphone signal, and audio signals from the 3 audio control panels. Select the forward-aft switch for the required audio source, forward for DVD-R1 or aft for DVD-R2. To erase cockpit voice recordings, make sure that the aircraft is on ground, weight on wheels is true, and the parking brake is set. Press the CVR erase button for at least a half second. The recording will be erased within 5 seconds of activation, which is indicated by a 3-second, 400 Hz tone from the audio monitor. No visual indication is supplied. Note, recorded flight data and ancillary information are not affected by the erasure command. The Digital Voice Data Recorder DVD-R system is capable of receiving, recording, and preserving all required flight data parameters and voice recordings on board the aircraft. It combines the function of a flight data recorder with the function of a cockpit voice recorder in a single solid-state recording unit. The Digital Voice Data Recorder unit is capable of recording the most recent 120 minutes of audio information from 4 analog input channels, 25 hours of flight data information received via an ARINC 717 bus, 120 minutes of digital communication messages, and Greenwich Mean Time, GMT, from an ARINC 429 source. The Digital Voice Data Recorder system has the following components: 2 identical digital voice data recorder units. DVD-R1 is installed in the forward E-bay. DVD-R2 is installed in the aft E-bay. 2 impact switches, one each mounted into its respective digital voice data recorder. 1 triaxial accelerometer, installed in the left-hand side wing stub area. 1 DVD-R control panel, located in the cockpit on the overhead panel. 1 cockpit area microphone, mounted on the frame between both windshields. Ten load cells, force sensors, 4 of which are mounted directly in the interconnection rods for the rudder pedal systems, 2 in the interconnection rods for the elevator control columns, and 4 installed in the command cables for the aileron control wheels. The Modular Avionics Units, MAU, are cabinets that house modules assigned to different functions in an integrated architecture. The MAU houses avionics and non-avionics functions. Among the avionics functions, the MAU houses air data application, autopilot, auto throttle, data acquisition, display control functions, flight director, flight management system, FMS, flight control modules, global position system, monitor warning system, stall protection warning, and wind shear guidance. MAUs 1 and 2 are located in the forward electronics bay, whereas MAU 3 is located in the center electronics bay. Aural warnings are used when the pilots require immediate knowledge of the condition without having to look at a visual display or indicator. Aural warnings are alert tones, like the single chime and the triple chime. Bells, to indicate an engine or APU fire or a cargo smoke detection, and voice messages used in systems like TCAS.
Increase, climb, increase, climb.
And EGPWS.
Terrain, terrain.
Aural warnings are canceled automatically when the alerting situation no longer exists, or when they are reset manually by the pilot. In the event of multiple alerts, the priority in order of highest to lowest is
Emergency, Level 3. Abnormal, Level 2. Advisory, Level 1. And Information, Level 0.
Aural alerts sound in a sequence and are never truncated. The electronic display system has two aural warning drivers that operate as master-slave logic and are responsible for generating and prioritizing the aural warnings. In case one aural warning driver is inoperative, the slave aural warning driver will automatically take over. If both aural warning drivers are inoperative, an aural warning system fail message will be shown on the ICAS display. When one aural warning channel is not operative, the indication is an advisory message, aural warn system fault. There are 4 levels of aural alerts: emergency alerts, abnormal alerts, advisory alerts, and information alerts. The emergency alerts are dedicated to Level 3 alerts and correspond to an emergency situation, such as an aircraft in hazardous configuration,
landing gear,
or serious aircraft system failures that require the pilot's immediate action. Abnormal alerts are dedicated to Level 2 alerts and correspond to an abnormal situation like the single chime for the master caution. Or the voice messages from the TCAS system.
Traffic.
Advisory alerts are dedicated to Level 1 alerts and correspond to a situation that requires the pilot's knowledge for recognition situations, such as when the autothrottle is deactivated.
Throttle.
Or the altitude alert.
Altitude.
When unintentionally departing the selected altitude. The advisory alert is a single alert signal that is canceled automatically. Information alerts, which are dedicated to Level 0, correspond to an information situation, such as when the aircraft is in the takeoff configuration.
Takeoff. Okay.
Or during a trim malfunction.
Trim.
ICAS messages. If both aural warning channels are inoperative, an aural warning system fail message is shown on the ICAS display. If only one channel is inoperative, an aural warning system fault message is displayed. A takeoff configuration warning indicates that the airplane configuration is not in a suitable takeoff condition. It is provided through the aural warning system. Such warning is activated whenever the airplane is on the ground, thrust is applied, and at least one of the following conditions is met. Flaps are not in takeoff position.
No takeoff. Flap.
Any spoiler panel is deployed.
No takeoff. Spoiler.
Parking brakes are applied.
No takeoff. Brake.
Or, pitch trim is out of green range.
No takeoff. Trim.
More than one warning may be generated if more than one condition is met. A test button is provided to allow checking the takeoff configuration. When the button is pushed, the power levers are simulated to the advanced position. If the airplane is in takeoff configuration, the voice message,
Takeoff. Okay.
is generated. If the airplane is not set to takeoff configuration, the aural warning referring to the associated takeoff configuration deviation is generated.
No takeoff. Spoiler.
The aircraft is designed and operates using the concept that when the engines are started, all systems are normal if the overhead panel, the main panel, the glare shield panel, and control pedestal panels have no striped bar illuminated. No aural warnings are being issued, and the selector knobs are all in the 12 o'clock position. In abnormal situations, the crew will receive visual alert indication that a system is not operating normally. The aircraft monitor warning system continuously monitors the condition of the various aircraft systems and shows alert messages and/or annunciations to the flight crew to inform the crew about the current system operation status. The color philosophy used to inform the flight crew is as follows. Red for warning conditions, flight envelope, and system limits. Amber for caution conditions, unavailable or invalid data, and miscompare annunciations. Cyan for advisory data, advisory ICAS messages, and pilot-selected data. Green for engaged modes, current data, and pointers in normal operating range. White for armed standby modes, status data, status CAS messages, scales, and associated figures and labels. To inform the flight crew regarding aircraft system status, ICAS messages are presented in the upper right corner of the ICAS display in a box known as the CAS field. There are 4 message levels: warning, caution, advisory, and status. Warning, red color, is used to indicate emergency conditions of an aircraft system or aircraft operation that require immediate corrective or compensatory crew action. Caution, amber color, is used to indicate abnormal conditions of an aircraft system or aircraft operation that require immediate crew awareness and subsequent corrective or compensatory crew action. Advisory, cyan color, is used to indicate operational or aircraft conditions that require crew awareness and may require subsequent or future crew action. Status, white color, is used to indicate information or status messages. That means when the appropriate action is taken, the pilot can make efficient use of the system. The ICAS messages are grouped and presented in chronological order according to their category. The warning category is at the top of the CAS field. Below this category, the system presents the caution, advisory, and status messages. When new warning, caution, and advisory alert messages are displayed, they are presented flashing in inverse video before acknowledgement. The warning and caution alert messages remain flashing in inverse video until manual crew acknowledgement via master warning or caution button, respectively, is pressed. After the acknowledgement, the messages remain in steady, normal video at the top of their respective category in the CAS field, until a new message belonging to that group appears. Advisory messages will be automatically acknowledged after 5 seconds when they become normal video at the top of their respective category in the CAS field, until a new message belonging to that group appears. A white end message, centered in the line, is displayed following the last message. The CAS field includes a status line out-of-view message display, which indicates the out-of-view ICAS messages. The purpose of this status line is to indicate the existence of undisplayed caution, advisory, or status messages, and their location relative to the currently displayed messages. The out-of-view message display includes the number of messages of each level, distinguished by a color, and an arrow indicating the direction of messages of each level, above or below the current window. The out-of-view message display, digits and arrow, flashes when there are unacknowledged messages out of view. The right out-of-view messages display represents the number of messages out of view below the displayed window, while the left out-of-view message digits represent the number of messages out of view above the displayed window.
An ICAS scrolling function is provided to allow the flight crew to scroll up or down through the active caution, advisory, and status messages which do not appear on the display. When the cursor control system focus is on the ICAS, the pilot or co-pilot CCD can be used to scroll messages. Both the inner and the outer rotary knobs on the CCD can be used to scroll messages. An icon shows when CCD is selected and is removed when CCD is not focused on the ICAS. Note: warning messages cannot be scrolled out of view.
ICAS message inhibition logic prevents certain messages from appearing during takeoff and approach or landing phases that would otherwise distract the pilots. The inhibition logic uses K-codes for specified ICAS messages or groups of messages to prevent their display during the different phases of aircraft operation. Inhibition logic considers the following K-codes to inhibit ICAS messages. For example, K3 code messages are inhibited during takeoff after 80 knots of speed until reaching 400 feet of altitude. The following table presents an example of how the CAS messages are presented in the aircraft operating manual. The section column represents the chapter of the AOM. The type column indicates the messages related to this AOM chapter and whether the message is a warning, caution, advisory, or status. The inhibition column indicates the K-codes for the dedicated messages or message group. The analog indicators used on the displays present valid data with a pointer in the same color as the respective indicating range. Note: for navigation, the color represents the selected source, which is green for NavAid and magenta for FMS. Unavailable or invalid data is presented by removing the pointer from its scale. For Aviate, air data and deviations, besides removing the data, a red X is added to the indication. The digital indication digits used on the displays for normal operation are presented in green. For Navigate functionality, the color represents the selected source for NavAid in green and for FMS in magenta. Unavailable or invalid data is presented by replacing the digits with amber dashes. In case of an exceedance, the digital indication is displayed in reverse video. The synoptic color philosophy used on the displays present their indications in green to indicate the on status, or in white to indicate off, or no air, or no fluid flow. Unavailable or invalid data is presented by a dashed symbol. In case of a failed component, an amber X is placed on top of the symbol.
The Electronic Display System, EDS, presents primary flight, navigation, and system information to the flight crew. The EDS consists of 5 display units, a guidance panel, 2 cursor control devices, CCD, 2 multifunction control display units, MCDU, ICUS full panel, 2 reversionary panels, MAU hardware including control input-output modules, and an EDS application software on dedicated processor modules. The 5 display units are located on the main instrument panel. There are 2 primary flight displays, 2 multifunction displays, and an engine indicating and crew alerting system, ICUS, display. The display units are identical. In case of failure of one display, an automatic logic transfer will allow its information to be presented in the remaining units.
All of the components require 28-volt DC power. The pilot's PFD, the co-pilot's MFD, the co-pilot's CCD, the pilot MCDU, and co-pilot's display controller are powered by DC bus 1. The co-pilot's PFD is powered by DC bus 2. The pilot's MFD and CCD and the co-pilot's MCDU are powered by the DC essential bus 2. The ICUS is powered by the DC essential bus 1. The pilot's display controller is powered by DC essential bus 2 via SPDA2. The electronic display system abnormal operation is the automatic and forced display units reversion. The 5 display units are numbered 1 to 5 from left to right. Only DU2 and DU4 can be reverted. DU1 and DU5 are always operated as PFDs, and DU3 is always an ICUS. Each pilot can manually select the desired display on the MFD screen via the display reversionary panel. The 4 switch positions are PFD, Auto, MFD, and ICUS. Setting the switch to a position other than Auto forces that selection onto the MFD. In this case, the failed reverted from display unit is shut down, and the display will be blank. When the switch is set to the Auto position, the system is in automatic reversion, with manual override capability, and it will detect many types of display unit failures. The reversion system will reconfigure the remaining DUs to the configuration shown. The guidance panel houses 2 display controllers and a flight guidance panel. The display controller has the following controls. The combined baro set, standard, units knob has 3 functions. Turning the baro knob sets barometric altimeter correction. Pushing the push STD button sets baro correction to standard, and selecting the IN HPA switch selects baro correction format to inches of mercury or to hectopascals. The combined RA baro minimum mode knob has 2 functions. The outer knob selects the source, either barometric or from the radar altimeter system, and the inner knob, when turned clockwise, increases the decision height. The HSI button toggles between full HSI and partial compass arc displays. The WX button selects weather data for display. The FMS button selects FMS as the primary navigation source and toggles between FMS sources. The BRG buttons toggle between VOR, ADF, and FMS bearing sources. The upper button, Circle, is for System 1, and the lower button, Diamond, is for System 2. The Preview button selects Navigation Preview. When FMS is the selected navigation source, It is used to display VOR, localizer lateral and vertical deviation, and distance on the HSI. The VL button toggles between available short-range navigation sources. The FPR button turns the flight path reference line on the ADI on and off. The display controller has the following controls. The combined barrel set standard units knob has 3 functions. Turning the barrel knob sets barometric altimeter correction. Pushing the push standard button sets baro correction to standard. And selecting the in HPA switch selects baro correction format to inches of mercury or to hectopascals. The combined RA baro minimum mode test knob has 3 functions. The outer knob selects the source, either barometric or from the radar altimeter system. The inner knob, when turned clockwise, increases the decision height, and when pushed, a system test will be performed. The HSI button toggles between full HSI and partial compass arc displays. The WX button selects weather data for display. The FMS button selects FMS as the primary navigation source and toggles between FMS sources. The BRG button toggles between VOR, ADF, and FMS bearing sources. The upper button, circle, is for System 1, and the lower button, diamond, is for System 2. The Preview button selects Navigation Preview. When FMS is the selected navigation source, it is used to display VOR, localizer lateral and vertical deviation, and distance on the HSI. The VL button toggles between available short-range navigation sources. The FPR button turns the flight path reference line on the ADI on and off. The primary flight display, PFD, is the flight crew's primary instrument. It provides display of aviation and navigation information as well as backup radio tuning. The PFD is divided into sections, each one presenting one group of information such as information regarding airspeed, altitude and vertical speed, attitude, heading, flight modes, and tuning comm, and nav. On the guidance panel, the display controller portion allows the selection of primary flight display HSI formats, navigation sources, weather display, and bearing pointer selection. Certain PFD internal failures will result in a blank PFD screen. In case of mismatched information between the two PFDs, a flag will be shown in the dedicated indicator. For example, a CAS flag is displayed whenever airspeed miscompare is detected, or a log flag whenever a localizer miscompare is detected. Here you see an overview of all flags which could appear in case of a PFD miscompare.
The multifunction display presents navigation information, shows aircraft's system parameters and status, and enables maintenance personnel to access maintenance messages on the MFD2. The MFD display consists of control and information areas. The menu soft keys, on the top and bottom of the screen, are used to select formats and control various systems. The selected information is displayed on the split-up screen. The cursor control device in the center pedestal is used to control the menu soft keys. Once a soft key is pushed, a pull-down menu is opened. Checkboxes in the menu are used to select and deselect each function. For navigation, you can choose between the map and plan formats. Weather radar, FMS, TCAS, and various other information can be shown or alternatively switched on and off. The system's menu has 10 sub-pages available. 7 pages are synoptic displays for monitoring the respective aircraft system and for fault isolation. These are the pages for status, flight controls, hydraulics, fuel, electrical, environmental control system, ECS, and anti-ice. The engine maintenance synoptic display shows the engine dispatch level limitations and exceedance data for the engines. The maintenance display is available only on MFD2 while on ground and supplies access to a maintenance system that is a combination of a fault recording and maintenance access system. The system configuration display supplies access to the Aircraft Personality Module, APM. Pushing the TCAS soft key opens the TCAS controller. Actuating the weather button pops up the weather radar virtual controller. The Engine Indicating and Crew Alerting System display, ICAS, presents engine indications, system parameters, and Crew Alerting System, CAS, messages. The engine instrument display consists of N1 display, ITT display, N2 display, and fuel flow display. Separated but appendant to engine indicating, there is the fuel quantity display, the oil display, and the engine vibration display. There is the slat, flap, speed brake display, the trim display, the cabin display, the auxiliary power unit APU display, and the landing gear display. The Crew Alerting System message window provides the pilots with displayed alerts. Remark: in case of failure in the ICAS display, its information may be presented in the MFD by appropriately setting the reversionary panel. The reversionary panel allows control of which display is shown on the MFD. It also enables selection of an alternate air data source and the cross-side inertial reference system. You can set the display's MFD mode selector switch to the following positions. PFD. PFD information is presented on the MFD all the time. Auto automatically presents the display information of the display that has failed on the MFD. MFD. MFD information is presented on the MFD all the time. ICAS. ICAS information is presented on the MFD all the time. In the event of an electrical emergency, the display selector knob is deactivated and the PFD will be displayed on MFD1 regardless of the knob position. With the ADS button, you can select an alternate air data source. A striped bar illuminates inside the button to indicate that it is pressed. Pushing the IRS button changes the attitude and heading source from the on-side inertial reference system to the cross-side IRS. A striped bar illuminates inside the button to indicate that it is pressed. The ICAS will be decluttered if the following conditions are met. The aircraft is flying in a clean configuration. Flap and gear up for more than 30 seconds and none of the decluttered parameters have been exceeded. If these conditions are met, the following items are decluttered during cruise. Oil pressure, oil temperature, low pressure vibration, high pressure vibration, gear position, flap position, slat position, speed brake position, the APU indication, and on the pitch trim scale, the green takeoff band will extinguish. Pushing the ICAS full button displays all of the decluttered items.
The following items are decluttered during cruise: oil pressure, oil temperature, low pressure vibration, high pressure vibration, gear position, flap position, slat position, speed brake position. The cursor control devices, CCD, are installed on both sides of the control pedestal panel. They allow the flight crew to quickly select the displays and position the cursor within the different selectable menus. The CCDs are primarily used on the MFD for selection of formats and functions. They also provide radio tuning on the PFD and ICUS message scrolling on the ICUS display. The cursor control device controls in detail are 3 format locating buttons. On the pilot's CCD, the left button places the cursor on the pilot's PFD. The center button places the cursor on the pilot's MFD. The right button places the cursor on the ICUS. On the co-pilot's CCD, the left button places the cursor on the ICUS. The center button places the cursor on the co-pilot's MFD. And the right button places the cursor on the co-pilot's PFD. The tuning knobs select the value or mode in the data field enclosed by the cursor. The touchpad is used to direct the cursor. The enter keys are used to select the soft keys.